Yes, good evening all. Good evening. Am I audible?
Yes, sir, you're audible.
Okay. So today we'll be starting with a new lesson. Actually, I just spoke to Manoj sir in the regard of the classes, which topic I just have to go through. So no problem, guys. We'll be considering the fresh, I mean, like present 12th batch, newly 12th batch, and we'll moving ahead. I'll be going with the relations, I mean, relations and functions today. Relations and functions. And Dhairya and Mohammed, if at all you find any difficulties for solving JEE questions, you may approach. Okay, you may approach so that we can conduct an extra class for them. Okay, people, Dhairya and Mohammed, you may approach in prayer so that we can have extra classes. I'm saying. Okay, right. Yes, I'm sure you might have learned in class 11th as well. Relations and functions you have learned in class 11th as well. CBSE students, board students, you also have learned. I mean, Dhairya, Mohammed, you might have learned in first year. Am I right? Okay. So here, what do you mean by relation? Can you now tell me? For suppose, yes, right, yes. Let's say this is set A and this is set B. Okay, 1, 2, 3. In set A, I'm having 1, 2, 3 elements. In set B, let's say 4, 5, 6. One can have a relation with 4. See, basically, relation happens between two things. Correct? Two things, two objects. We say. So one can have a relation with the 5 here. One can have a relation with the 6 here. Two can have a relation with the 4 here. Two can have a relation with the 5 here. And someone is texting. Yes, Adya, you're right. Yes. Look at this. 2 to 6. 2 may have relation with the 6. 3 may have relation with 4. 3 may have with 5, with 6. All right. Now, how I represent relation from A to B basically. This is how I represent. A or B is nothing but relation from A to B. Okay. So A cross B. How do you write A cross B? I'll write 1, 4, 1, 5, 1, 6. Already you have learned all this. So let me go from the basics one more time so that you can recollect. 2, 4, 2, 6, 3, 4, 3, 5, 3, 6. Correct? So A cross B, this is what A cross B. Okay? Correct? Yes. What is A cross B? How do you define A cross B here? Set of all possible relations. Set of all possible relations from elements of set A to elements of set B. That is how you define. How? Set of all possible relations from elements of set A to elements of set B. I'm not writing the theoretical definition, but you just have an idea what is that. Okay. A cross B. This is how you write. Now, I'll just give an example. Look at this. A R1 B. I'm taking a relation from A to B and relation name I'm giving as R1. Okay. The relation from relation from A to B is, let's say that R1 is X comma Y such that X comma Y such that X, or you write Y is equal to X plus 3. Y is equal to X plus 3 for all X belongs to A and Y belongs to B. What is the meaning of this? How do you read this as? What is this form name actually? This is set builder form, correct? I'm sure you might have learned in school stage as well.
Yes, sir.
Set builder form, correct? Yes. So how do you read this? R1 is equal to X comma Y such that Y is equal to X plus 3. This is the condition given to you. For all X belongs to A and Y belongs to B. The meaning of this is, if you are writing an ordered pair, in that X coordinate, which means an abscissa, that will be belonging from set A. And your ordinate, I mean to say that your Y coordinate would be belonging from set B. All right. Yes. So this is a set builder form given to you. Let's write in roster form now. So what is going to happen is R1 can be written as, see, basically I need to write ordered pairs. That's it. That is the roster form. Now by elements, what are the elements given to you? 1, 2, 3, 4, 5, 6. Set A is 1, 2, 3. Look at this. Same elements I'm taking here. Set A is what? Set A is 1, 2, 3. And set B is 4, 5, 6. Correct? 1, 2, 3, 4, 5, 6. Now let's write ordered pairs. So Y, X, let's say that X is equal to 1. Then what is the Y is going to be? 4. If I take X value 2, what is the Y is going to be? 5. If I take X value 3, what is Y is going to be? 6. Correct? Getting my point? This is the relation.
Yes, sir.
It is going to form. Now, if you observe here, look at this. I said that X belongs to A, and sorry, for all X belongs to A and Y belongs to B. Now here, look at the X elements. I mean X coordinates 1, 2, 3. Here, all this X coordinates, they belongs to set A or not? Check. 1, 2, 3. They belongs to set A or not? Yes, they are. Now Y coordinates 4, 5, 6. They are belong to set B. That is what I meant to say in the given relation. Look at this. That is what I meant to say here. Getting my point? Here 4, 5, 6. They are Y coordinates. They are belongs to set B. And this, look at this here. X coordinates 1, 2, 3. They are belongs to set A. They are belongs to set A. So this is your answer. Getting my point? This is a basic example. This is a basic example. Now, let me tell you one thing. What is this form? This is a roster form. Everyone know that. Okay. Next, what can we discuss? Sir, you wrote one relation here. Is this the only relation going to possible from set A to B? No, there could be many relations from set A to B. Okay, I just took an example that this is a relation. Y is equal to X plus 3. By taking this condition, I just framed one relation. There could be many relations, something like that. All right, there could be many relations like, X is equal to Y plus 4. There could be any relation. There could be many relations. Now, let me write. Everyone, it's a very important point. Everyone write this note. If R is a relation from set A to B, then R is subset or equivalent A cross B. This is very important. Can anyone of you explain me what exactly the meaning of this statement? Quick. Can anyone of you?
R is a subset of A CrossB?
Yes, whatever the relation you get. For suppose you take set A and set B, and from those two sets, if you frame a relation, that relation, whatever the relation you get, that would be subset of A cross B. A cross B is what? In fact, that is a Cartesian product between A and B sets. Correct? Yes. The relation whichever you get, that would be a subset or equal to A cross B. So if you want me to show practically, I'll show one example. 1 second. Look at this. Very simple. If you want to see an example, look at this. This is the example. Let's see. Look at this here, R1. This is R1 I got. Now check whether this R1 is a subset of this A cross B or not. Check. Check kar lo. 1, 4 is available.
Yes, sir.
2, 5 is available. 3, 6 is available. Yes, R1 is a subset of A cross B. So what you understood, whatever the relation you take from any set, from any sets, that would be subset of A cross B. R1 is subset or equal to A cross B. Very important note. Next, one more important note. This is a note number 1. And next, 1 second guys. This is a note number 1. Next, note number 2 is total number of relations. Total number of, what happened? Total number of relations from set A to set B. Okay, this equal to 2 to the power of n of A into n of B. Okay, n of B into n of B. N of A into n of B. N of A is what? Number of elements present in set A. They were 3. Number of B is nothing but number of elements present in set B. They were also 3. So 2 to the power of 3 into 3, 9. So from the sets given to you, A and B, from those two sets, the number of relations is how many? 2 to the power of 9. Understood my point? Total number of relations from set A to B is what? 2 to the power of 9. Hope you got the point. All right, number of A into number of B, 2 to the power of. Now I'll give one more example. Anjali, why are you late, Anjali?
Sir, I was late by 10 minutes, but I've been trying to join, but I think you were taking the class, so you couldn't see that my thing was like, I was waiting in the wait room.
When did you join?
7 or 11, sir.
Okay, no problem. Then what you have to do is you just drop me a message immediately. Then how come I'll be maximizing the screen. I'll not switch back again to the Zoom and just
I did, sir. I did in the group and then deleted it.
Please, whenever you get stuck something like that, you just drop me a message in WhatsApp. So I'll be having phone next to me.
Okay, sir.
I'll be checking the WhatsApp regularly so that I can admit you. I'll be maximizing the screen. I don't know what's happening in the background. So for looking at that, I have to switch back again to the Zoom and just admit you. Okay. If I look immediately, I'll admit you. But if I'll be in the class, I'll be busy with teaching something. So you'll be losing something.
Yes,
right?
sir.
So please don't do that. Okay.
Exactly, sir.
Right. So A R to B. This is what the relation given to you. Now relation 2. What is the relation 2 given here? X comma Y such that Y greater than X for all X belongs to A and X belongs to B. Now, sir, you didn't give set A and set B. You take same sets. What were the sets here? Set A was 1, 2, 3 and set B was 4, 5, 6. Okay. Yes. Now tell me the relation. This is a set builder form. Write the roster form. Quick. Y greater than X. Y greater than X. Quick. Quite simple, common sense की बात है, ठीक है? Make it fast. Look at this quite simple process. Look at this R2 can be written as, बस हमको क्या लिखना है? Ordered pair लिखना है बस, ठीक है? You have to write ordered pairs. So 1, 2 Check in 1 comma 2 whether y is greater than x or not. Yes. Now 1 comma, or else you write like this, 1 comma 4, 1 comma 4, let's write, not 1 comma 2. Why? Because 1 to 4, right? 1 to 4, or you write 1 to 5, 1 to 4, 1 to 5, 1 to 6. In every ordered pair, y is greater than x. Next, you can write 2 to 4, 2 to 5, 2 to 6, 3 to 4, 3 to 5, and 3 to 6. Hope you are getting my point. Here, look at this here. X is 1 beta, y is 4 beta. X is lesser than y, or you say y is greater than x. Both एक ही meaning है ना दोनों. Both are giving you same meaning here. Correct? Yes. So this type of relations, whenever you get this type of conditions, this type of relations are universal relation. This type of relations are called as universal relation. Now, can I write this as simply R2 is equal to A cross B here? Do you agree with my point? See, whatever the ordered pairs I got, this relation can be written as what? A cross B or not? Set of all ordered pairs possible from set A to B. That is what A cross B. Okay. Now, this type of relation, therefore, R2 is an universal relation. What is that? Universal relation. Getting my point? Hello? Yes. Now, let me change the question. Let me change the question. You can take a note as well, no problem. If anywhere you get any relation which is equal to A cross B, such type of relations are universal relation. You may write a note like that as well, no problem. So if you want to write like this, let me write any relation from A to B. I'm taking relation. I'm giving the relation name as R3. Sir, why you are giving R1, R2, R3? Why can't you give simply R? You can give any name. R1, R2, R3. You may give any name beta. See here, R1, R2, R3. Why I'm giving that? Yes, the intention of giving like that is, so I'm giving you different relations with the different conditions. That is the meaning of that. Okay, they are relations. Huh. Let me write a relation with x comma y such that x comma y such that x greater than y for all x belongs to A and y belongs to B. All right. Yes, this is what the relation given to you. You make sure that you are checking it properly, then you confirm it. All right. Yes, everyone just confirm this once, please.
Sir, it is not possible.
Oh, 1 second, Adesha. No, 1 minute. 1 second, guys. 1 second. Be in line. Yes, stay tuned. Yes, guys. Tell me. So what type of relation is going to be? Yes, I just
Sir,
said
it
that
is not possible.
it's not possible. Check kar lo. Dekho, here R3 is going to be what beta now? Any, none of the ordered pairs is going to possible here. Look at this. X can't be greater than Y beta. Correct? See, nowhere possible. Check kar lo ek baar. Look at this. 1, comma 2, comma 3. B is equal to 4,
Sir,
comma
it is a
5.
null set.
It is a null set. Very good. It is a null set. So whenever you are not getting any ordered pairs, okay, such type of relations are what? Therefore, such type of relations are what? Empty relation. R3 is R3 is an empty relation. Hope you got the point. Understood my point? Getting or not? Yes. Huh. Next. Now I'll give one simple example. Huh. First, everyone take a note. After this note, I'll give an example. Okay. For suppose any relation, let's say that A cross A, from set A to A. First of all, okay, let's write example or note, then we'll go for example. Let's say that set A, from set A to A, you have a relation. Okay, what is the meaning of this? You are writing a relation from set A to A. Okay. And let's say R2, which is also from set A to A only, but you are getting empty relation, or else you give a name called R2, which is an empty relation. R1 is a universal relation, in fact, isn't it? A cross A is nothing but, if you are getting any relation as like as their Cartesian product, such type of relations are universal relation. I told, right? Let's write that relation, universal relation. Then this is what? An empty relation. Empty relation. Okay. Now combinedly, if a relation, listen to me, if any relation is a universal and empty relation, both such type of relations are trivial relation. What are they? Trivial relations. A very important point. Okay. If a relation universal and empty relation, both means that is a trivial relation. Okay. Next. Now let's see an example. One more example. Now let's write let A is equal to set a 1, 2, 3. Okay. Now we are taking what? Relation. Look at this here. Relation A, R, A, which is nothing but relation from A to A. What is the meaning of this beta? Relation. I'm writing a relation from set A to A. 1, 2, 3 is a relation. 1, 2, 3 is a relation. Correct? From set A, I have 1, 2, 3. Here also set A. So let me write 1, 2, 3. Now let's write A cross E. Why A cross A? Tell me. Why? Because I'm writing a relation from A to A only. So I'm writing a relation from A to A. So let's write A cross A first. A cross A. Common sense. Look at this 1, 1, 1, 2, 1, 3. 1, 1, 1, 2, 1, 3. Oh, 1 second. 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Correct? 2, 1, 2, 2, 2, 3, 3, 1. Oh my goodness. 3, 1, 3, 2, 3, 3. All right. So this is what you just got here. Okay. Now I'll give a relation. I'll give a relation now. Let's say that R1. I'm writing R1, which is X comma Y, such that X plus Y less than or equal to 6. For all X belongs to A and Y belongs to also A only. Why? Because writing relation from A to A. Okay. Huh. Now write this in order. Write the order pairs of this set builder form. Right? Write that. X plus Y less than 6. 1, 1. Yes, 1 plus 1, 2. Still less than or equal to 6. 1, 2. Okay. Everyone write that. What you are getting? Tell me. Quick. If you observe this properly, again you will be getting the same. Okay.
So same.
Same thing you are getting. Look at this here. If you want, you can check. Look at this here. 1 plus 1, 2. Here 3, 4. Again 3, 4, 5. Again 4 here, 5, 6. So all these numbers are less than or equal to 6 or not. Summation of all these ordered pairs, beta. Summation of all these x and y in all ordered pairs still lesser than or equal to 6. Am I correct? Yes. So what type of relation? Now, what is this relation is called? As inversal relation. Therefore, R1 is equal to here A cross A, right? Now this can be written as A cross A here. Right here. Here R1 is equal to A cross A. Therefore, R1 is equal to inversal relation. Okay. R1 is what? Inversal relation. Now I'll give one more relation. Same thing. R2 I'll be giving you. R2 I'll be giving you. X comma Y such that X plus Y greater than 6. For all X belongs to A and Y belongs to B. Okay. Now let's write this. Right. Arrange the order pairs of this. X plus Y greater than 6. Is there any order pairs you are getting where summation of X and Y coordinates greater than 6? Is there any ordered pair you are getting? Summation of their coordinates is greater than 6. Check kar lo. Are you here?
Yes, sir.
Yes, that is an empty relation, beta. So none of the R2 is equal empty. Therefore, R2 is R2 is an empty relation, correct? Yes. So therefore, R2 is an empty relation. Now look at this here. R1 is inversal relation. R2 is an empty relation. Now combinedly this relation is what? Now trivial relation. Understood my point? Trivial relation. So that is what I meant to say here. Hope you got the point. Getting my point, beta? Look at this here. If you these two relations are trivial relation on what? On set A. Very important point. Look at this here. This relation, beta, and this relation. Both are trivial relation. Okay. These two relations are trivial relation on set A. Okay. Yes. If you want, you can write neatly. Okay. Yes. Next. I'll give an example. One question will solve one question. Okay. A is equal to set of all students of a boys school. I think this is your textbook example only. Very good example for understanding. Okay. Set of all students of a boys school. Okay. Let me write a relation as A comma B such that A is a sister of A is a sister of B. Okay, so set of A is what here? In fact, here relation is what? Relation. One second. Let me write something like this, somewhat down here. What is relation here? I'm writing a relation here. Relation in R. Relation in A. Okay. What is the meaning of this? I'm writing a relation from where to where, beta? A to A. I'm writing a relation. From where? From set A to set A. What is set A given to you? Set of all students of a boys school. Set of all students of a boys school. Now let's say this is set A. Let's say this is set B. Okay. Sorry, this is also set A only, right? We are not talking about B here. So in boys school only boys will be there. Boy 1, boy 2, dash 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 dash. You will be having in boys. Here also boy 1, boy 2, dash 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 dash, n boys will be there, correct? Now I'm talking about a relation from A to A. So A cross A is going to be what now? What is that A cross A? B1 comma B1, B1 comma B2. If you write ordered pairs, you can write till B1 comma Bn dash 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 till Bn comma B1, Bn comma B2. One second, Bn comma B2, Bn comma Bn. Okay, this is ordered pair I'll be getting. Now what is the relation given to you here? A comma B. A is what here? It is belongs to set A, and this B also belongs to set A only. A is the sister of B. Now what type of relation is this one is going to be? What type of relation this one is going to be? Guys, what type of relation this is going to be? Make it fast. What happened? Common sense. This is empty relation, right?
Yes, sir. It will be an empty relation.
Why? Why? Tell me.
Because it is totally this boys' school, sir, so there will be no girls in that school.
Yes. Look at it. So here A comma B, both here, both are boys. Okay. So A can't be a sister of B. Correct? Yes. So what type of relation is this? It is an empty relation. So therefore R is an empty relation. Okay. Now let me give one more relation here now. R1. Okay. Let's say R1. Same set you take A comma B such that difference between the heights of A and B is less than 3 meters. Less than 3 meters. Less than 3 meters. So tell me what type of relation this one is going to be. Make it fast.
Sir, this set is possible.
Sorry.
This relation is possible, sir, but I'm not getting like what particular like term it is used, sir.
Yes, it is possible. Think. Common sense. Here you have to apply a logic. Very simple logic. You have. See here, A comma B here. What is A here? What is B here? Both are belongs to set A only. This is also set A. This also belongs to set A only. Now think. Now let me take this.
Sir, trivial relation, sir, because first relation is empty and second one is universal.
That yes, that's what I'm saying. So what type of relation is the second one? How come it is A?
Sir, universal, sir.
How?
A into A, no, sir. You only said that A into A means it is a universal, sir.
No. A into A nahi. A cross A is a universal relation. I said that. But how come it is A cross A? What is that? Whether no. See here, relation one. 1 second. Relation one is, if at all any relation is A cross A, that is universal relation. I said. Now my question here is, the given relation is matching with A cross A or not? That's my question.
It is matching, sir.
How it is matching? Tell me. How come it is matching? Tell me how. See here, common sense.
Sir, but in the relation they didn't give that whether it is less than 3 meters or not. Like this statement is not given.
No. Statement is given. The statement given to you here is difference between A and B is less than 3 meters. Dekho, I'll be telling you now. A cross A. What is A cross A? It was, look at this. A cross A was this one. Correct? This was A cross A. Let me write here. This was A cross A. Correct? Yes. So here, if you take a difference between A and B, okay, let me take this ordered pair. Okay, let's say this is A here, this is B here. Difference between boy one and boy one is boy one and boy one is what? What is the difference between their heights? Difference between same height, beta. Lekho, this is boy one, this is also boy one. What is the difference between their heights? Both are having same height. Zero to hoga na, isn't it? Getting my point?
Yes, sir.
So minimum difference is what? Minimum difference between their heights is equal to what? 0 meters. Okay, you said 0 feet. Okay, the maximum difference could be what? Maximum difference between their heights is what? Any two you take, beta. Look at this, B1 and B2 I'm taking. So let's say that एक लड़का boy one, let's say that कोई ले लो 9 feet का बच्चा है, ठीक है, 9 feet, and B2 let's say that कम से कम, this is the maximum, this is the minimum. 1.5 feet का तो आदमी होगा ना, कम से कम तो 1.5 feet तो होगा आदमी, उससे कम तो नहीं होगा, ठीक है, हाँ होगा, तो secondary case, no problem. So let's take that second person is 1.5 feet, the first person is 9 feet. So what is the difference between B1 and B2 now? What's the difference? 7.5 feet.
Yes, sir.
7.5 feet is still what? Less than 3 meters or not?
Yes, sir, it is.
It is less than 3 meters. So now you take any case. You take any case. Now look at this. So I can write now this ordered pair is possible. This ordered pair is also possible. Every ordered pair will be giving you the matching condition to the given relation. So B1 comma B1. This ordered pair would be matching with this relation or not. This ordered pair would be matching with this condition. This ordered pair also would be matching. This ordered pair, this ordered pair, this ordered pair. Every ordered pair you take from the A cross A, every ordered pair would be matching with the given relation. Why? Minimum, come से कम minimum difference between their heights is what? 0 feet, which is less than 3 meters. Is satisfying. Maximum ले लो, maximum 7.5 feet है, तो 7.5 feet is still less than 3 meters. समझ में आ रहा है आपको? Getting my point, people? Isn't it? Understood my point?
Yes.
Every ordered
sir.
pair will be satisfying. So that is the reason why we are saying R1 is a universal relation. That is the reason why we are saying R1 is an universal relation. Hope you got the point. Okay. So now we'll talk about types of relations. Now we'll talk about types of relations. I mean, special types, like, whatever the now universal relation and empty relation we just spoken about, they are also types of relation only. But now whatever we are going to learn, these are like special types. These are very important. This is a very important exam point of view. Okay. Types, sorry, not types, identity. Identity relation. Okay, identity relation. First one is what? Identity relation. Oh my goodness. Identity. What do you mean by identity relation? See, let me write. Let R be a relation. Let R be a relation in set A is said to be an identity. Said to be an identity relation when every element of set A is related to itself only. Okay, so what is the meaning of this? Let's say that set A 1, 2, 3, another 1, 2, 3. So relation from set A to A. What he has given the definition, R be any relation in a set A is said to be an identity if every element of set A is related to that itself. So 1 should map with 1 only, 2 should go and map with 2 only, 3 should go and map with 3 only. Understood my point? So 1 should go and map with 1, 2 should go map with 2, 3 should go with 3 only. So you can't say that 1 go with 2 and 2 go with 1. It's not like that. It's not going to possible like that. Getting my point? So for suppose, let me write an example here. Any relation you take like this, 1 comma 1, 2 comma 2, and 3 comma 3. Okay. Now check whether this is an identity relation or not. Yes, it is an identity relation. Why it is an identity relation? Why? Because every element is mapped with itself. Okay. Now identity relation. This is an identity relation. Now let me take one more example. Let's say this R1. Let me give this R2. Let me write 1 comma 1 and 2 comma 2. Check kar lo whether it is a identity relation or not. It is not an identity relation. Not an identity relation. Not an identity relation. Why it is not an identity relation? Because 3 comma 3 is missing here. What I told in the definition, every element should related to itself, I said. Correct? Every element should be related to itself, but every element is where you have here. You don't have, right? You are, you are missing with 3 comma 3 here. Getting my point? Understood my point? Is it clear?
Yes, sir.
So now Next, everyone take a note now. Everyone take a note. Identity relation is unique. Identity relation is unique. What is the meaning of this? Identity relation is unique is nothing but identity relation unique is nothing but every set, whatever the set you take, for every set there would be only one and only one identity relation. You can't find more than one identity relation for a single set. Understood my point? So you take a look at this here. I took one set here. What was the set I took? Set A. Let set A is equal to 1 comma 2 comma 3. Okay, this is the set I took. For this particular set, beta, this particular set, for this particular set, there is only one identity relation, which is this one. Okay, you can't have more than one identity relation for one set. Okay, that is why identity relation is an unique. Identity relation is unique. Okay, is an unique. Hope you got the point. Okay. So next type of relation is reflexive relation. Reflexive relation. Reflexive relation. Understood identity? Identity is nothing but what? Look, double elements. You say the double. Look at this 1 comma 1, 2 comma 2, 3 comma 3. If you don't have double elements, then that is not identity. Simple logic. Getting my point? Getting my point? Reflexive is nothing but what? Let me write our relation. A relation on set A is said to be said to be reflexive relation if A comma A belongs to R for all A belongs to set A. So for suppose what I meant to say here is, let's take an example. Let A is equal to 1 comma 2 comma 3. Okay, and let R be a let R be a relation in set A. Let R be a relation in set A. Okay. So for condition for reflexive relation is every element must be related to itself and can be, or else it can also be related to other elements. Can also be related to other element as well. Okay, can be related to other elements as well. So what is the meaning of this? So every element must be related to itself is nothing but, so first of all, for identifying a reflexive relation, you have to check whether it is an identity relation or not. So if it is not an identity relation, that is not going to be a reflexive relation. So for saying a relation as a reflexive relation, that must be an identity relation. Okay, and now let me write an example. So what I said here, and it can also be related to other elements. So if I give an example, you will get the point. Let's say that one A comma A is what? 1 2 3 I took. So let's say that any relation, let's write R1 1 comma 1, 2 comma 2, 3 comma 3, and you said 2 comma 3. Okay, and now look at this here. Yes, it is a reflexive relation. Now it is a reflexive. It is a reflexive relation. Why it is reflexive? Because here look at this here, 1 comma 1, 2 comma 2, 3 comma 3. Yes, this is a mandatory case beta here. Mandatory case. This is a mandatory case. And other elements is what? Maybe, like, may or may not be possible. Look at this, maybe may not be possible. So this is, you say, this is optional. It's optional. Okay. What is the mandatory case here? What is the mandatory case? Having doublets, having same elements is a mandatory. Other elements may or may not be there. So that type of relation is going to be reflexive relation. Getting my point? So what you understood from this? For saying reflexive, that must be an identity first of all. If it is an identity relation, definitely it is going to be reflexive. Sir, it like 100% it need not to satisfy identity only. So if you have all all double elements like this, and there could be other elements as well, but mandatory case is what? Double element should be there. That is a mandatory. Other can be there, other may be there, may not be there. Okay, let me write R2 here now. Let me write now 1 comma 1, 2 comma 2, now 3 comma 1, and 3 comma 3, and check. Now tell me here, this is a reflexive relation. The first R1 is a reflexive relation, but not identity. Not identity, correct? It is not identity relation. Identity relation is nothing but only double elements. Other should not come. In reflexive, identity, double element should be there, others can be there. That is the condition for reflexive. Now check whether the R2 is a reflexive or not. Yes, first double elements here, here, here. Double elements are there. So it is an identity. Okay, I mean satisfying identity condition. Now look at this guy is extra here. Okay, so it is a reflexive relation now. Yes, my job is to check whether they are having double elements or not. Yes, everywhere I have double elements. Fine. So and other elements can be there, cannot be there. So it is a reflexive. Now check whether it is an identity or not. Yes, not an identity. Not an identity relation. Why? Why? Because in identity only double elements should be there. Other than double elements, no other element, I mean no other order pair should be there. Okay. Now let me give one more relation so that you will get a clarity. 1 comma 1, 2 comma 2, 3 comma 3. Now check whether it is a reflexive or not. Check whether it is a reflexive or not. Check whether it is a reflexive relation or not.
It is so.
It is reflexive relation. Look at this here. It is reflexive relation. It is reflexive relation. It also an identity, isn't it? It is also an identity. What was the condition for reflexive? First of all, you have to check all doublets are there or not. Yes, all doublets are there. Okay. Others may be there, may not be there. Yes, इधर नहीं है तो क्या फर्क पड़ेगा? ठीक है, तो it is a reflexive now. So identity is also possible. So this is what the reflexive relation is all about. So reflexive relations could be many beta. It is not like identity relation. Identity relation is what? Identity relation is an unique of every set, but not reflexive. Reflexive could be many. Okay, reflexive could be many. So I'm stopping here. After this, we have a note. We have a note. After in the next class, I'll be discussing you about reflexive relation in a much better way. Okay, by giving an example, we'll be solving in the next class. All right. Yes. Thank you. Have a nice day.